Hey everyone and welcome. As IT professionals, we are obsessed with redundancy. We've got plans for everything. Hardware failures, power outages, malware attacks. But what if I told you there's a threat that could knock out all of your redundant systems at the exact same time? And what if that threat was coming from 93 million miles away? Let's get into it.
All right, before we jump in, just a quick heads up. This is part 2 of a 10-part series. We're digging into a really detailed report from the folks at RFI Detectives. And in this particular explainer, we're honing in on Chapter 2, which is all about space weather. And yeah, the invisible forces that could literally take down your entire infrastructure.
So let's just start with a big question to kind of frame our thinking here. You've locked down the server room, you've got redundant power, redundant everything, but have you ever stopped to consider this? What if the single biggest point of failure for all your critical systems is actually the sun?
To even begin to answer that, we've got to define what we're actually talking about. And don't worry, we can forget the dense astronomy textbook stuff. We're going to look at space weather from the perspective of an IT pro who just needs to keep the lights on. Okay, so here it is, the official definition. The key words here for us are variable conditions from the sun that directly affect our tech. And not just satellites up in orbit, but systems right here on the ground. This isn't science fiction, folks. It's a very real operational risk. You can think of it as electromagnetic interference, but on a cosmic scale. And that leads us to this quote from the source material, which I think just nails it. Why is it the least intuitive? Well, because we can't see it, we can't touch it, and the source of the problem is literally millions of miles away. And why most devastating? Well, that's exactly what we're about to unpack. All right, now we get to the single most important concept in this entire explainer. Seriously, this is the part where space weather completely flips the script on how we think about IT resilience and disaster recovery. So the number one danger, the thing you really have to understand, is this idea of correlated failure. See, in IT, we build all our redundancy on one fundamental assumption, that different systems will fail independently of each other. A server dies, but the other node in the cluster takes over. A switch fails, but the backup switch is totally fine. Space weather completely violates that core assumption. And this is exactly how it happens. You have a single event, let's say a massive solar flare, that slams into Earth's magnetic field. Now, this doesn't just cause one little problem. It causes a whole bunch of problems all at once. Suddenly, your GPS timing, which your network relies on, is completely off. Your satellite WAN links are dropping packets like crazy, and the actual power grid itself is becoming unstable. 3 totally separate systems all failing from one single root cause. So let's just break this down. Your network, it probably uses GPS for precise time synchronization. Your remote sites, maybe they rely on satellite links. And your power, well, that's everything, right? A severe space weather event puts all of these at risk at the exact same time. That is the correlated failure nightmare. Okay, so that's the threat. It's massive, it's cosmic, and it can break all our carefully crafted rules about redundancy. So you're probably thinking, what are we supposed to do about it? Well, the really good news is we can take this huge abstract threat and turn it into concrete metrics we can actually watch. And here is the best part. You do not need to be a solar physicist. The source material makes this crystal clear. All we have to do is start thinking about solar activity in the same way a data center in Florida thinks about hurricane forecasts. It's just another environmental variable we need to track. And this right here? This is our toolkit. These are the NOAA Space Weather Prediction Center's scales. They're all simple 1 to 5 scales. The G scale tracks geomagnetic storms, the ones that mess with power grids. The S scale is for radiation storms that can damage satellites, and the R scale is for radio blackouts that disrupt things like GPS. So for example, if you see an R3 alert pop up, you know you need to start watching for GPS timing issues. You can literally add these metrics to your existing dashboards.
So let's pull all this together. What does this all really mean? Well, it means we need a pretty fundamental shift in our mindset when it comes to risk management. We have to start thinking way beyond the 4 walls of our data center.
And this slide just sums it up perfectly. We're moving away from that old model of planning for independent, one-off failures to a new model. A model that understands that a single external environmental event can cause a whole cascade of simultaneous failures across systems we used to think were completely separate.
And this is the final takeaway, a direct call to action from the report we're analyzing. If your business depends on GPS timing, satellite links, or even just a stable power grid, you have to treat space weather just as seriously as you treat fires, floods, or any other threat on the ground. It absolutely belongs on your official risk register.
So I'll just leave you with this final thought. You've done all the hard work. Your data is backed up, your network has failover, but have you looked up? Have you accounted for the one threat that can bypass all of that planning? Is space weather on your risk register?